looked at it, I thought I would go through a few of the problems that I think are interesting or informative. For this video, I'll probably do ones that are a little bit more on the straightforward side, and then for the video that I'll put out um, later in this week, I'll do some that are a little bit more complicated or probably more confusing. I'm actually going to start with 1 through 4 because these are questions that I have changed this year, so they're actually not on the review that I will be posting later this week. So I'll just get the answers up here. And I'm going to use a text box. Let's see. Question number 1. A radius that bisects a chord must also be perpendicular to that chord. That's a property that we're going to be using to figure out some stuff later on. Number 2, the measure of a blank angle is half the measure of the intercepted arc. That is an inscribed angle. An angle with a vertex on the circle. The measure of a blank angle is equal to the measure of the intercepted arc. That, of course, is a central angle, something that we'll be using in just a moment. And then finally, number 4, a tangent to a circle is blank to the radius which it intersects at the point of tangency. That is also perpendicular. Let's see, I'm going to skip around a little bit, but I do want to do this problem. Actually, I'm not going to do the problems themselves, but I'll get some of these measurements on here so that you'll be able to answer these questions. And of course, the answers are less important than understanding how to do it. So I'll try to explain what I'm doing as I'm getting answers. Start with the information that we're given. The measure of angle DBE is 24 degrees. And this is an inscribed angle over here with this arc DE as an intercepted arc. So if DBE is 24, then this arc must be double that, 48 degrees. And if this intercepted arc is 48 degrees, then this angle in here, angle DCE, must also be 48 degrees. Let's see. Since both of these, and actually this one also, are radii of this circle, that means I've got some isosceles triangles. Triangle ECB is an isosceles triangle, which means that the two vertex angles would have to be the same. This one must be 24 as well, 24 degrees. Which means, let's see, if both of these are 24, we're going to be able to find what the other angle in this triangle is. Let's see, 24 and 24 is 48. 180 minus 48 is 132. And if this angle ECB is 132, then its intercepted arc must be 132 degrees. Also, we are just flying through this. That might be all we can do so far. Let's take a look at the other information. Arc AB is 98 degrees. And if that intercepted arc is 98 degrees, then the corresponding central angle must be 98 degrees. Triangle ABC is an isosceles triangle, again, because two of its sides are radii of the circle. So if I know the vertex angle is 98 degrees, I can do 180 minus 98 and get, let's see, that must be 82 degrees. And so these two angles, angle CBA and CAB, total combined must be 82 degrees, which means each one is half of that, which is 41 degrees. And then looking at angle ABC over here, that's 41. It's an inscribed angle, so its intercepted arc must be twice as big as 41. This must be 82 degrees out here. If arc AD is 82, then its corresponding central angle must be 82 as well. Let's see. Segment CD and segment CA are both congruent. They are radii of the circle. I have a hard time marking this one as congruent just because there's other stuff going on here. But by that logic, if this is 82 and angle D over here and angle CAD have to be the same, then I'll do 180 minus 82 and get 98 degrees. So these two angles together must be 98 degrees. Each one is half of 98, which is, in this case, 49. And I suppose I could have used that as an inscribed angle from arc AB and figured that out in a different way. These two angles together would be 49, but I'm not sure yet how big each one of them is, but I think we can figure that out. I'm going to go to this. I've got this big isosceles triangle here, triangle ACE, and I know that these two angles together are 130, 82 and 48. I believe that's 130. And so if I've got 130 degrees used up between these two angles, 130, let's see, that means I've got 50 degrees left over for angle CEA and CAE. And so if those are a total of 50 degrees, each one must be 25. 25 degrees there and 25 degrees here. And then we already said that this angle DAC has to be congruent to ADC, again, because that triangle ADC is an isosceles triangle. So if this part of that angle is 25, then the other one must be 24, so that those two angles add up to 49 degrees. And then we've got, in these triangles, the only angles I'm missing now are these angles down here. I don't even know if I asked about any of those, but I'm going to go ahead and figure that out. Let's see, I guess it doesn't matter much which one we use, so I'm going to go with this triangle ADF and say that if angle D is 49 and angle DAF is 24, I'll add those together and get 73. And so 180 minus 73 gives us 107. And then we go back to the very beginnings of this class and say that these two angles are vertical angles, so this one is also 107 degrees. And then these two angles, DFE and EFC, are a linear pair, which means if one of them is 107, then the other one must be 73. So this angle down here is 73, and this angle up here is 73 degrees also. And so there we go. I haven't answered any of the questions. At least I haven't tried to. I'm going to guess that I've answered all of them. All of those answers should be found on that diagram. Moving along, let's see a couple of the questions. 32 is going to be a nice straightforward one. If segment WY is 40, let's see, VX is 24, so I can mark this as 24. VY is 8. And WY was 40, so if WY is 40 and VY is 8, we've got 32 left over for WV, and they want us to find XZ. Well, I'm going to find this one first. I'm going to find segment VZ, because the property of chords that we learned in this chapter is that the product of the parts is the same for both chords. So I'm going to say 32 times 8. Let's see, I think I'm going to go back to a text box for this. 32 times 8 must be equal to 24 times x. And then I can divide both sides by 24 and get x is equal to whatever 32 times 8 divided by 24 is. And 32 times 8 divided by 24, where's my calculator? I got that to be 10 2/3. Did I plug that in right? I'm always worried when I get these decimal answers. Vx24 yv. Yeah, I think this is right. So I am getting x equals, oh, what's going on? X equals 10 2/3. And so if this is 10 2/3, then we'll just add 24 to get xz. So 24 plus 10 2/3 is 34 2/3. So there we go. And I will put up my answer key for this eventually. I'm just not going to do that just yet. 37, this would be a good one for us to take a look at. This is more about the angles. We are given that arc WX is 68 degrees. Notice that the intersection point here is not at the center, so I can't use central angles and inscribed angles. But I can use the property that says if I've got an intersection like this inside of a circle, then this angle is going to be the average of these two intercepted arcs. And so I will just I'm going to stick with the text box so this is legible. 68 plus 46 divided by 2. And I'll plug that in my calculator. 68 plus 46 divided by 2. And I got this angle to be 57 degrees, the average of those two. Again, just add them up and divide by 2. And I believe WVX, yep, that's the angle that we're looking for, so that is my answer. So that's a big property. Obviously, something like that will be on the test. Again, what just happened here, this angle is the average of these two. So add up those two intercepted arcs and divide by 2. Careful, make sure that I'm not asking for one of the other ones. We'd have to use linear pairs to figure that out. But I wasn't asking for that on this one. 38 and 39, this is a property that we actually didn't do this year. So you can skip 38 and 39. And 40, we didn't do what number 40 is asking for, but we did do what 41 is asking for. Let me see. Yeah, this one's pretty straightforward, but this will be good for us to take a look at. We are looking for this angle, PRM, and we're given that arc PM is 156 degrees. Arc NQ is 38 degrees. So with the one that we just did, we said that that angle inside the circle was the average of the two intercepted arcs. This is going to be different. This angle is going to be half of the difference between these. Instead of adding them up and dividing by 2, I am going to subtract and divide by 2. 156 minus 38 divided by 2. And for that, I get 59 degrees. Oops, it won't let me do the degree symbol, so I guess I'll just draw that in. But that's it. That's that type of a problem. And then maybe, let's see, let's maybe finish up with, let's take a look at one of these where we've got a tangent to the circle. We haven't done any of those problems. WX is 27. ZY, this one out here is 25. And XY is 45. Oh, so this one is asking, is it tangent? It looks like it is, but we'll find out if it's tangent by verifying that it is perpendicular to this radius that it would be tangent at. Key thing here is that I've got a radius there of 27, which means I've got another radius here of 27. And now if the Pythagorean theorem is going to work, if this actually is tangent, then a squared plus b squared will be equal to c squared. 27 squared plus the other leg is 45, 27 squared plus 45 squared. And that's the question. Is that equal to this length, which is, let's see, 27 and 25 is 52. Is it true? And so I'll just plug these, oops, in my calculator. Didn't mean to do that. 52 squared. So 27 squared plus 45 squared. So on the left side of the equation, I get 2,754. Is that equal to 52 squared, which I got to be 2,704, and it's not. So because the line is not perpendicular to that radius, it is not a tangent to the circle. I'm just going to take a quick look and see if there's anything else I want to do today. I think I'm going to probably save the rest. Oh, let's do one of these. Equation of a circle with the center at -3, 5 that is tangent to the y-axis. So if it's at -3, 5, 1, 2, 3, 4, 5, if it is tangent to the y-axis, that means that its radius is going to have to be 3, so that it just comes by and barely touches on the y-axis. So if my radius is 3, that means my equation will be x minus the x value. X value is -3, so x minus -3 looks like x plus 3 squared, plus y minus the y value. The y value is 5, so y minus 5 squared equals the radius squared, and the radius is 3. So there it is. There's my equation. And so you've got a couple problems using the equation of a circle. Okay, I am going to stop at this point, continue to work through the review. If you have any questions or if you have any requests, if there are specific problems that you'd like to see me go through that I didn't do today, let me know and I can certainly go through those in my next video. Otherwise, we will talk to you all later. Bye-bye.